kind of what I do.
But welcome. My name's James Russell. I am the interim CTO at Unizin, and joined by my colleague, Heather. You want to?
Yeah, hi, and thanks for having me. I'm excited. I work at Venable, and I do a lot of work around AI policy and regulations and helping folks understand them and feel good about them. So let's see what we can do here today.
Perfect. And part of this too is I'm excited because of the really compelling and thoughtful keynote this morning. I think there's going to be a lot of overlap, and since so much churning around policy and almost the philosophical components of AI now are surfacing, so looking forward to our discussion. So just a bit of a roadmap. We're going to focus as sort of the centerpiece on AI policy standards, best practices, and regulation broadly, anchored in the White House Executive Order on Safe, Secure, and Trustworthy Artificial Intelligence, and kind of offshoot from that, some of the NIST documentation, in particular NIST framework, AI framework, that kind of anchors the operational components of the EO as well, and then discuss Unizin's connection with this from a policy standpoint, but also potentially from a operational standpoint, and how kind of policy and best practices would animate that instance of applying AI in the consortium. And then hopefully we have time to allow for questions, comments, discussion as well. So I think this quote from EO, from the executive order, is really a near perfect distillation of our discussion today. In the end, AI reflects the principles of the people who build it, the people who use it, and the data upon which it is built. That is as comprehensive and all-inclusive statement as I can think of. And I think it is a metaphor beyond that for a really thoughtful set of documents that we're going to be citing. And I think the executive order is one, and I think the NIST documents, my experience with NIST has largely been around security controls, and I'm kind of blown away about, in particular, what we're going to reference, and I'll reference the AI portfolio. Really comprehensive documents with really smart people that have put some deep thought into this. So it's really exciting to kind of see that prior art. So what is expressed in this opening statement reflects, I think, a kind of feedback cycle that is in itself representative of AI systems in their mutually reinforcing way of operating. That the builders of systems or social products themselves and bring preferences and biases to the design of these systems. And that's its use. How AI is applied is a social artifact too. We make assumptions about the results. We use those products or results of AI in structured ways. We, in turn, feedback into those systems personal and systemic bias. And the data itself that trains models that may have the same conditions in play. In fact, there's no doubt they do. Plus a myriad of shapes and configurations and completeness or lack of completeness that you find in sort of the operational components of data. So the product of AI is always contingent, no matter how magical. So without providing clear practices or unpacking this, oftentimes relative to the exceptionally complex and opaque systems, and in a way, in the keynote this morning, Tom brought up how it aligns with the internet and the growth of the web. This is very parallel to that, but there were technologies in place that made that, in a way, understandable and translatable and transparent. There's so much that is potentially opaque. And I think one of the pieces that both the kind of critical centerpiece of the executive order and NIST imperatives is this concern, this fundamental concern of eroding public trust, which is another way of saying we'll accelerate through AI the degradation of truth.
So we wanted to start off with some discussion, setting that baseline for what these AI systems do. Um, and one of the things that I like to point out on the early end is that a lot of the definitions in the EO, in policy, in law are very broad. But we're really talking about using computers to make decisions, make predictions, look at huge amounts of data, create create outputs and decisions and scores and that kind of thing. We're increasingly seeing really cool AI systems, really advanced, more advanced AI systems that look creative or perform tasks that we think of as requiring human cognitive skills. But really, they're all very, very data driven. We've put the OECD definition for artificial intelligence here. Machine-based system infers from input how to generate outputs based on that, like predictions or content or recommendations. And I like to kind of tell stories on how broad that is. When I hit the reheat button on my microwave, that's AI. But we're talking about something a little bit different here. And the executive order and a lot of the laws, policies, regulations out there are actually much more narrowly scoped. But it's useful then to say, okay, they're all defining AI with something a little bit like this definition. So we'll look a little bit too at how they've scoped some of these rules to make them really much more applicable, because you don't actually want to regulate your chatbot the same way you regulate AI in your car or in a microwave or any of those.
Yeah, and I'll add, I think the challenge is not only around the efficacy of what AI does, but is how AI arrives at its products transparently and understandable to a broad audience. And what the EO and the NIST, again, what Heather is stating is an AI risk assessment management framework in particular, and what we're going to discuss today sets forth in great detail mandates and practices of the how. As well as making accessible or more readily apparent, transparent how AI can be effectively and ethically applied. And two sort of sidebars, I'm going to reference a couple of notions of models, and one is just a data model, and that represents the structure and organization of data, and I'll kind of anchor that in the Unizin common data model. And then generally, an AI model is a particular, and again, very general algorithm or AI technique based on what you want to represent or a problem that you want to solve and the characteristics of the data that you're going to use. And that data is going to train and validate.
So let's talk about this executive order. It came out in November of last year. We are just over the 150-day mark for it. It's 111 pages long. It's incredibly detailed. It's got well over 100 actions for the U.S. government, the federal government, and agencies to undertake. And it really applies very broadly. It starts with some principles around safety, responsibility, labor, equity, consumer protection, privacy, workforce, and global leadership. So it kind of covers the world. But there are some very clear implications for folks working in education, both the people who are educating directly and working on skills for the workforce, but also for the way that we apply artificial intelligence in an educational context. And particularly, some of those principles are very important as they do that. And to what James is saying, NIST has done some very impressive work already, and it is doing more around how you apply these principles in context and how you think about applying them, because obviously the context is going to matter. You can't say, I'm going to apply this in my car the same way I'm going to apply it in a classroom. They're focused on those best practices and standards, as well as that workforce piece. And that's seen throughout that 111 pages. But there are also a few pieces that are very specific to the educational context. I will run through this. This is kind of the framing. They're thinking about innovation. How do we make sure that US remains very competitive, remains innovative? How do we make sure that our workers are prepared for an AI future? And how do we make sure that the federal workforce is there? How do we think about educating new grads? How do we think about upskilling the folks who are already in the workforce? How do we make sure that these technologies are safe and that people feel good about them? How do we make sure that they reflect, equity and civil rights, and that they're really protective, and that they take privacy in mind? We're talking about a huge amount of data here, and we're talking about using data in ways that maybe we didn't think about. One of the big takeaways is that a lot of the existing pieces of the puzzle that are out there addressing all of these things, they already apply and they already do a pretty good job. And so the EO is looking at a few places where there might be gaps, and making sure that we really understand them. Next slide, please. Thanks. There's a focus, there's a lot of concern that technology takes over jobs. And I, as the eternal optimist, tend to think that we will see a lot of jobs evolve. And that we'll see a lot of folks who maybe don't have the most interesting jobs, because they're going to get, more automated. I question whether they will become fully automated. Certainly the vast majority won't. If anybody's been playing with some of those large language model chatbots, you see where some of those limitations are. But on the flip side, I think that there's going to be more and more tools available to everyone, and the EO spends a lot of time on that. How do we make sure that people are equipped to use these tools and know enough about these tools to do a good job with them, and to feel good about their job, and to feel good about how these things operate? There are a few protections in here. Don't use AI to track your workers in ways that you can't legally. Using other tools, how do we support, as opposed to kind of end up in this dystopian science fiction movie, which is an outcome I fully support. Not doing a dystopia thing. Also, next slide, please. And then there are some pieces that are very specific to educational institutions. The EO has about a half page on the Department of Education. But there's also some resources out there that have already been established that are also worth looking at. The Secretary of Education was directed to develop resources, policies, and guidance regarding AI, and thinking about where there might be gaps, where they might want to put out more guidance, and where they might be able to help. As well as resources on how to use AI safely, responsibly, and in a non-discriminatory way. Those are three big words. They all require definition, and they all require some fleshing out. We'll talk a little bit more about that when we talk about some of the NIST standards. But generally, they're thinking very specifically about contexts that are going to take a little bit more scrutiny, and where people are already a little bit more careful. They're already regulated, they're already using technology in interesting ways, and they already have programs around some of these things. We want to make sure that they are reflective of these new tools. They're very focused on kind of making sure that impactful decisions have human involvement. And human review. They're thinking about, enhancing trust and safety. You don't throw tools at a problem if you don't trust them, one hopes. And thinking about what the right boundaries for that are. Thinking about what it means to be in a world where we're using AI for more and more things, and we're throwing more and more data at our computers. How do we do that responsibly and compliantly, particularly in the educational context? And then thinking about whether there need to be education-specific guardrails. So those are forthcoming. I believe, I want to say June or July, so soon. But there's already a report that I actually really like called AI and the Future of Teaching and Learning that the Department of Education put out last year. It's worth taking a look at. I was very impressed with it, because clearly it's folks who actually understand how people learn. Some of the resources that are coming out about AI are not the most accessible, but I thought that actually the education one was quite nice. You want to go to the next slide? Oh, and turning it back to you, James.
Thank you. So Shifting to Unizin and Unizin member concerns broadly, there are a number of existing pieces, I think, already in play that are certainly relevant to the EO concerns and mandates, and draw kind of on previous art. First, leveraging existing Unizin and consortium expertise and use cases. I mean, this is part of the power of the consortium. We have a wealth of academic and institutional research expertise in play with existing use cases, not necessarily in AI, although there's one fairly long-standing at the University of Iowa utilizing AutoML and machine learning toward pass-fail prediction, but use cases really in learning analytics and for some time. And I think a lot of the interests around policy and the concern around ethics and privacy that has come up through learning analytics initiatives and concerns over learning analytics animate and the same areas in AI as they do and have for some time. We're policy driven, at least foundationally. We rely on member agreements. We have workflows and processes that are intimate in terms of our FERPA relationship with members. They're very important that we follow process. We're just necessarily policy driven based on our consortium kind of environment and climate. We can build a common vocabulary and understanding, and this is one of the key pieces, I think, that separates maybe an internet that was also brew out of years of understanding the OSI model and some standards there and all of that were kind of in the realm of IT for some time. There's so much that's new, and there's so many differing opinions about what terminology and standards mean. And so I think we can build through the consortium to advance kind of a common understanding of AI principles and language through our teaching and learning communities. Learning analytics guiding principles. This came up again out of a concern to allow members, or at least give members a framework to ethically engage at the very least this new area of having learner and learning environment and learning process data, and how do we sort the differing priorities and interests, and how do we keep the kind of ethical mandate or imperatives of protecting students' privacy while also using their data as a common good is something that advances their success and learning. So also prior art, and this learning analytics guiding principles is something that Unizin developed as a consortium, and I can see something like this evolving, not just around policy of, say, generative AI or a specific field, but really holistically, and using the NIST standards that we're going to talk about as guiding principles as well. We have what I think is a beta of synthetic data that represents our modeled UDP data that is safe and highly representative data across the consortium for testing and evaluation. So now we can apply training using data that's not touching production data, but has the look and feel of data that makes sense across the consortium. And this is a really exciting component for us in a variety of ways. If we look at acclimation to what is possible in the UDP, as well as applications for training AI models. Unizin members control their data within a single tenant architecture. So if models shift to production within for an institution, that data is never commingled amongst members. That's always sequestered. So we have a mandated institutional control over member, learner, and learning environment data through our infrastructure, and controlling governance that is as important, that puts institutional concerns first. Institutions control what data is sent to the UDP, they control who has access to it, and they vet and understand fully the use cases to which that data is put. So all of those pieces, I think, are in really strong infrastructure, both policy and actual, that supports AI innovation within the consortium. And then finally, we are established on standards. I'm going to shift next to talking a bit about NIST standards, but Unizin has essentially two standards in play. Our Unizin Common Data Model that is has been developed out of our relationship, certainly a strong relationship with Instructure and Canvas Data. All our members are Canvas customers. It's grown out of the unique engagements with institutions and their SIS. It is founded on the CEDS model, the Common Educational Data Standard. And there's the analytics interaction that we have with our members that tweaks, that looks at possible entity additions, it looks at option sets, it's organic. So it has a logic, it has 90 entities that are related and representative of learners and the learning environment, the learning ecosystem within the digital sphere. But it is also not static. It is something that is growing and becoming what we always intended it to be, and that is a better and better representation of how learning happens. So shifting then to NIST, it really hinges on a couple of things. Those standards start with the AI risk management framework, and I'll talk a bit about that. And then sort of subsuming this all is this collection of AI documentation in which the EO and the AI risk management framework sit, among other things. That's the NIST AI portfolio, and it's really impressive. And within that, I felt that there was a really interesting opportunity here to talk about some sort of fundamental pillars, and fundamental AI research brings that to bear on three areas: bias, explainability, and security. Bias is massive. Throughout the NIST documentation and the EO is an emphasis on socio-technical perspectives. And again, I can't say enough of how inclusive and thoughtful and broad-reaching, while also anchoring in depth, these documents are. And they emphasize this understanding of both systems and people, and the complex interplay between technical and social processes. And it goes back to our opening reference. And just looking at the sidebar, extracting one piece from this special publication towards a standard of identifying and managing bias in artificial intelligence, this could easily apply to higher ed, in specifically to our learning ecosystem. And individuals and communities interact in and with an environment that is increasingly virtual, and we could say is increasingly driven by online learning resources, or the LMS. They are often vulnerable to the commodification of their digital footprint. Again, this is I think a simple statement, but a far-reaching one, and it also has applications to students, not only in terms of our relationship with ownership of data and our relationship with vendors, and the students sort of being in the middle and both institutionally engaged and engaged with vendor products, but it's also comes back to just their data and issued. So we have concepts and behavior that are ambiguous in nature, are captured in this environment. And this is a concern of learning analytics for as long as I've been at Unizin and before, that can we make this distinction between the activities that we see in the learning management system, for example, and whether those are indicative of engagement or a richer understanding of whether the student is deeply immersed in their work or not, or whether they need a kind of intervention or nudge. So all of these things are already existing as potential challenges and pitfalls, and we have the mechanisms in process and sensibility to deal with them. It's just, again, that AI accelerates it. And then if we look at that diagram beneath, we have the same kind of idea captured in the initial statement, the initial citation, and that is, we have these specific systemic challenges under the surface, and we have human biases also under the surface, and they inform our operational and statistical and computational proclivities and what we do with that data. So there is certainly a mutually reinforcing piece here, and I think that diagram does a great job. So taking this further, there are three critical areas that are focused on in this special publication. First, how bias in AI can erode public trust. Again, this is a central feature and focus and recurrent through all the documentation and operational documentation, in particular relative to the public perception of certain data used without consent, for example, or data used to unfairly judge individuals. And again, that compromise of what constitutes truth is something that is part of our time, certainly with digital media, certainly with challenges in elections. All of that is, I think, heightened in these particular documents. So if we look at the first of the identified three categories in bias, systemic, and this has gotten incredible attention, and rightly so. Embedded institutional bias that operate in ways which result in certain social groups being disadvantaged or favored, or others being disadvantaged or devalued. We have certainly statistical concerns and computational biases stemming from errors that may result from a sample not being large enough or representing the population. Error may be due to heterogeneous data or representation of complex data reduced to simpler mathematical representations. All of these concerns, I think, need this kind of transparency, and this is our challenge. We need language wrapped around them that makes sense to a broad audience, and we need to build workflows that are built on transparency. And then there's the human bias, and I think this is a really interesting quote, and I'm going to quote it literally here because I think it has so much potential to clarify, and it also just underscores how good and thoughtful these documents are. Human biases reflect systemic or systematic errors in human thought based on a limited number of heuristic principles and predicting values to simpler judgmental operations. Wow. Unpack that, but if you do, it is a wonderful way, in a way, to talk about the continual problem that you have making generalizations about a population or a group from a very small bit of data. And the kind of elegance of that expression, to me, kind of blew me away when I first read it. I really appreciate how thoughtful these documents are. Moving down then to primary challenges, sort of reproduce this, but are kind of more specific in terms of mitigating bias. Data sets, simply put, the data that is collected may poorly represent the world from which it is taken. Sample size, again, incomplete. Is the data appropriate to the domain of the inquiry? And missing contexts. And that's, again, comes back to our understanding and learning analytics. When we look at student activity, and there's a particular application use case Indiana University conducted and is engaged in, called the Canvas Activity Score, that looks at students potentially at risk based on some very transparent and simple parameters. That information on those students in the bottom two octiles is then moved to student success teams, and they can see the context. They add a potential depth to it. And I think when we get down to human factors, that will come even greater in focus, that we need that contextual piece to it. Testing and evaluation, examining algorithms, data employed, fairness metrics, all of that are important. And then again, what I referenced, human factors. Are there humans in the loop? And opportunities to bring in responsibly domain knowledge to mitigate and access bias in the same way that a student success team would take that and contextualize those students that may be absent for reasons that are never captured in the LMS or sent in any kind of way through an activity metric. Oh, and I wanted to show this again to not belabor a point, but this is a really cool diagram that is part of that special publication that really opens up a kind of taxonomy of relationships that I think takes the complexity of AI and bias, in this case bias, and makes it more important and or transparent rather, and gives us at least an ability to ask questions. I mean, opening it up this way, seeing the relationships between these layers of bias and thoughtfully aligning it with a scientific tradition is really, really cool in my view. So.
It is very cool that they kind of integrate all of that in something that is seen as so technical. Yeah. And recognizing that interaction feels very important to me. And so also struck by it when I first read some of these documents, that socio-technical aspect. But they're really talking about what makes this unique. I think another of the focuses from NIST is around explainability, which is my favorite. Used to be not a real word, but in the AI context, it's definitely a real word. And the goal there is very much to help us understand what we need to understand about AI, because it can so often be a black box. But explainability is a set of tools and principles that help us understand what we need to know. You know, why is a system making the decisions or predictions or suggestions that it is? You know, how understandable is it to the end user? How understandable is it to the deployer? How are these systems creating their process? And what situations is the tool appropriate in? I think that last one is incredibly important. My biggest fear is not that the robots will rise up and you know, take over the world. My concern is that someone will put one of these systems in a place where it isn't appropriate and it's not designed for, and it's actually just not good at that job. And so explainability is one piece of that, is helping people understand what a tool is good for. The piece of it that you know, your chatbot can be very, very good. You know, first thing I did with the chatbot was I had it write a song for my dog, and it was amazing. It blew my mind. But I would never want that chatbot to be in charge of admissions. I would never want that chatbot to tell me, you know, what's going on my website. I might want it to help with some of these things. Maybe it can do some summarization. But anyway, explainability is really important as we move into this AI-powered world, so that these more complex systems and the ones that really act more like a black box and are less easy for people to intuitively understand, that we have ways to explain them. And the quote on the side, AI must be explainable to society, not just to the nerds. I love us all. We're the nerds. But, you know, we need to be able to help tell the story of what these tools are doing and why they're doing them and why we chose them. And then, you know, the kind of original NIST framework, or at least the first one that I ran into in the tech industry, is the AI cybersecurity framework. And so they bring over a lot of that work into the AI risk management framework, because a lot of the questions about AI security are the same as any other software. There are also some unique pieces they pull out in the AI risk management framework as well, but they are looking to all of the work that they have done before in order to inform the way that they approach the socio-technical piece of artificial intelligence. And there are a lot of pieces of this that are worth knowing about. NIST is in the process of developing some new guidance around generative AI and the use of generative AI. They're thinking about red teaming, which is kind of a broadened approach from some of the security testing that you might traditionally undertake. But also not just looking at how can I break the system, or how can I get into the system, or how can I find the data, but also how can I make the system do things it's not supposed to do? Kind of not only looking for the vulnerabilities in the system, but how do we test the system for unanticipated behaviors or flaws? And then thinking about how you test for the impact on people. That's a hard one. But it is something that NIST is working on, and we have some ideas about ways to think about that. But all of that is kind of packaged up into some of this AI safety and security work. They are developing profiles at a rapid pace. They are thinking about how AI applies to existing frameworks and how this all can kind of knit together in a way that makes things easier instead of harder. They're also thinking about AI in the context of secure by design, which is a set of principles around how you develop software and how you deploy that software, and really making sure that you can shift the security thinking earlier in the process so that it doesn't come up to kind of bite you at the end.
Great.
Go ahead.
Thank you. Okay, so now I'm going to look at sort of a hypothetical Unizin data platform use case to take some of those three pillars of bias, explainability, and security, and shape them around something that's possible, and in the process talk a bit about the UDP. So just at a very high level, just for some context. The Unizin data platform aggregates data. It brings it in from the primary sources on the left, from the student information system, from the Canvas learning management system, and associated tools that integrate within that learning management system. So the UDP itself is infrastructure. It's our platform. And at the other end, we have reports, we have dashboards, we have folks writing SQL against it to generate unique reports, and we could have AI models potentially. And the key piece here is that all of this infrastructure is really designed to present data through a model, through the Unizin Common Data Model. And to present that data in ways that it takes the disparate sources on the left and aggregates and harmonizes and makes them all sensible under one worldview of learners, learning environments, and learning processes. So that's, in a nutshell, what the UDP does. So if we look at this hypothetical use case, I think it's at least compelling as a metaphor for what is possible. And so we have this diagram off to the right. That person could be speaking or writing. But one of the complexities of this understanding and using the UDP for members is that you have to have an understanding of a model that is beautifully documented and logically oriented across 90 entities in a relational database. But you have to understand the nuances of that domain, which is, again, wonderfully documented, but it takes time. It also takes time and expertise to write SQL against that database to get responses and to understand and do research. And so we're always looking at ways to streamline that process of moving from data to information. And we can do this through our wonderful analysts and architects that assist folks in writing SQL at member institutions or consulting. We can create reporting mechanisms that compact and compress the SQL in an automated way to present data only to folks. And potentially, we could have a natural language interface on top of the UDP that would allow people to actually ask questions of it. But I think it's important to say that this question, say, what biology courses have the least student activity, from the very beginning is potentially hobbled or at least constructed. So it could be hobbled by bias, or at the very least, it's structured logically through a request that makes sense, but that's where the structure begins. And so we have baked into this, how is least activity measured? We create a MART to have different variations of activity. So there are decisions that we make. They're transparent and documented and rational, but they are decisions. We are looking at to understand student engagement from this. Well, then there could be a whole series of things we're leaving out, or we may never even scratch the surface of what it means to be an engaged student here. So there are caveats from the very beginning at the prompt level. But let's say we can ask questions in sort of for the sake of argument. I think we can address nicely bias, explainability, and security here. We have a transparently built model, so we understand the structure of the data and we understand the data integrity. And we also can understand the efficacy of the AI model employed, because ideally we would expose the SQL that it generates to generate the response, the table, the language that says how many students in biology are, quote unquote, have low activity. So that piece is nicely transparent, and the bias is as well. It doesn't rule out the bias, but it makes it transparent. And then in terms of explainability, we can actually have folks that routinely write SQL against with the same interest as the person asking the question, and generate validation and say, you know, I got different results from applying this SQL. We may want to tweak how it interprets language to then code it. Whatever it is, I'm leaping here in advance, but we can test it. And then finally, in terms of security, we can build out proof of concept using synthetic data that never touches actual data, but has, again, the look and feel of logical distributions across the consortium as a whole, with no ability to pinpoint an actual student, course, instructor, or assignment, and then randomly create, based on those distributions, data. And we can use that data potentially in a safe way. And then when we're ready for beta, institutional members can work only with their data within the confines of their tenant. So just an interesting use case that sort of extrapolates on these NIST standards that we're looking at. And finally, and I know we're getting down to time, I want to just kind of throw some concluding thoughts here specific to student data and AI. And this is, if we look at the concerns relative to learning analytics in general, and how privacy in particular, but certainly also confidentiality and security, these are our realms. Privacy is more in the purview of our members. They play an accelerated role in AI, best practices, regulation, compliance, as they have in learning analytics, but accelerated. And I think the following holds true specifically in the realm of institutional analytics AI involving student data. And it's really part of, I think, where our brains have been with learning analytics in general. And I think that Stuart Selber this morning really hinted on it. This learning's messy, and that we should not confuse a learner data with data that helps the institution. That's a separate endeavor, and that as long as institutions are committed to applying learner and learning environment data specifically towards student success, I think these ethical arguments around privacy will be, they won't go away, but they will be assisted to a huge degree. Especially for institutional analytics, institutional or academic research has a different set of goals. They're interested in learning processes. If student success comes out of that, great, but it's a different agenda, and it has a different set of checks and balances in terms of IRB and anonymized data and all of that. But when we're looking at students and intervening with students, I think the clarity around student success has to be there. Second, institutions have to be committed to communicating their position, saying we use student data derived from the learning ecosystem to benefit students. And we're not going to use it in ways to increase enrollment. We're not going to use it in ways to improve the profit margin or the bottom line. And then third, be transparent about what you're doing. Show how the data is being used, what data is there, and what the efficacy is. Is it doing good? Because all of this is designed to, again, move students in the best way possible forward in terms of their academic careers and their learning and becoming powerfully responsible citizens. So I think all of this is tied in very interesting ways and can evolve. And I know we're right at a minute at a time. We had a few questions. I can't see questions now. It looks like it's. I'm trying to figure out if folks are answering questions or asking. Mariah said that she would post them if there are here. But I know we're nearly at time. But it's been a pleasure. Thank you so much, Heather. And we will. Look forward to next year or the year afters and see where we are with AI in the consortium. Thank you all.